Hi, welcome to AWS Elastic Cache presentation. This is a web service offered by Amazon. This presentation will be covering a brief overview about this web service, how this web service helps in increasing the performance of an application, and then we'll be doing a demo about how this cluster, Elastic Cache cluster can be created, and talking about a couple of its salient features. Node Auto Discovery and CloudWatch. This is the outline of the presentation. So, in-memory cache is basically a mechanism to improve the performance of an application. The data is stored in the cache rather than on the disk, so it helps the application to restore the data faster. So, basically, Elastic Cache is a web service that helps us to deploy in-memory cache in the cloud. It is help the it helps the application to improve the latency and throughput of read-heavy applications such as media sharing and social networking. The main customers of it are YouTube, WordPress.com. So it supports both the Memcached and Redis caching engines. It can be integrated with other uh, AWS services such as CloudWatch. It basically helps in adding and deleting the cache nodes, at detecting its failure. So we can have a cluster up and running without worrying about the software hardware issues. So this is a picture of how Elastic Cache cluster looks like. So here is the client application running, and this is our cluster. So these caches, these nodes are the part of the cluster, and the client will be talking to this cluster. So as I mentioned, we'll be talking about the feature, one of the most important feature of Elastic Cache cluster, which is auto discovery. This is supported for Memcached. It basically enables the auto discovery of cache nodes by Elastic Cache clients. So when the nodes are removed or added to the cluster, this feature helps the client to detect that cluster changes automatically. This is how it works. The application is running here, and here is our cluster. So the application connects to the endpoint, configuration endpoint of the cluster, which is basically DNS records of the nodes, and which in return gives one of the target node, and in the cluster, all the nodes have information about its peers. So when the cluster client connects to one of the nodes, it can get the information about all the other nodes in the network in the cluster, and thereby it gets what are the clusters there, and if one of the nodes go down, it's easier for cluster client to detect that. So CloudWatch is a service provided by Amazon. It monitors metrics. When it is integrated with Elastic Cache, it provides both host level metrics and metrics specific to cache engine. Some of the recommended metrics are CPU utilization, swap usage, eviction, and current connection. I'll give you an example of CPU utilization, how this helps. It's basically host level metric, and if the CPU utilization of a node is really high, say it's 90%, then basically it means that the node has been beaten up and it needs to be upgraded. So, develop a application which will create a cluster, and this application is called AWS Elastic Cache Jar. And if you want to run this application, you will have to change the code is also present in the folder, and you have to change the credentials for this application to run. And what this application will do is it will take the input of number of nodes and the cluster name, and the type of node, and it will create a cluster for you. So let's see the demo. So I run this here. So I want to create the file number of nodes, the number of cluster, name of the cluster is example cluster, and the type EC. So number of clusters is created, and now when we go up here, refresh this, we see the cluster is being created. So this is the code for the application AWS Elastic Cache.jar, and it's using my credentials. So if you have to run it, you have to use your credentials. Limitation of this application is that it deletes all the nodes in the cluster. So I will have to manually delete one or two nodes to show how node auto discovery works. And this was another snapshot of that it creates a cluster. Uh, so to showcase node auto discovery feature, I created another application called Node Client.jar. This application is written in Java. It is also available at AWS console, but I had to make changes to the application, so I downloaded the code from this website, made the changes, and compiled into the jar file. Uh, this once the application was compiled into a jar file, I copied to the EC2 instance and then ran that application and saw how it's detecting the cluster changes. The scenarios that I tested was I deleted the cluster manually, I added the cluster manually, rebooted the cluster, and changed the interval of time when I'm deleting the cluster or adding the cluster. So let's go and do the demo for this. Mm, So since this is still coming up, we will use the existing cluster that we have, and this is the EC2 instance that we will log into. And it takes the configuration endpoint as a input, and we that will be this it will be this value, and see it started pulling the configuration. It detects that there are two nodes, node 003 and then node 004. And if we go back and see here these two nodes, 003, these endpoints, and now if I try to add another node, um, so, so it's start pulling and we'll have to see. So it hasn't detected the new node that has been added yet, and it's still in creating. So let this node come up. Meanwhile, we'll continue with our presentation for the lack of time. This is basically the output of this. And then this is the CloudWatch when it's used with Elastic Cache. It it gives the specific metrics for each node. And for example, here the utilization, if it reached up to 90%, then if it is a small node, we can upgrade it to the large node. Or if the current connection is way too large, then we can. This is the application interaction of the application. Elastic jar creates the cluster, and then Northline jar monitors that cluster. That's before we detected. It probably seeing the change, and this node is up. And it says connection state changed. It has detected the change, and it used this endpoint to pull the information. New endpoint that has been added to the cluster. So it has the host name rd.f8gg6003, 004, and 001. It has detected that. So the summary, uh, Elastic Cache web surface is very helpful. It helps us build in cache cluster without worrying about a lot of details. Auto discovery feature helps us to detect the cluster changes without resulting in downtime and manual intervention. It polling interval is also adjustable, so we can, if it impacts our application too much, we can increase the time of polling. Um, so things that are not so good about no no auto discovery is that it is only compatible with Memcache, and it polls every minute at the minimum. So if the applications are added or deleted very fast, then it may client may go to a node which has already been deleted without knowing that. And also we saw that it took some time as we were waiting for it to um, notice that a node is added. So when a node is deleted, it is much faster, but when a node is added, it takes a little long. So that's what is all covered in the presentation. Thank you. Have a nice day.